Welcome, beginner game developers, to this comprehensive guide on handling keyboard and mouse input in Unity 3D and Visual Studio. Visual Studio and Unity 3D are essential tools for game development, enabling you to bring interactive experiences to life. Effective input handling is crucial for creating engaging games, allowing players to interact seamlessly with your virtual worlds. Our objective today is to guide you through implementing keyboard and mouse input in both environments, using C# for scripting. First, let's set up our development environment, starting with Visual Studio, an integrated development environment, or IDE. Visual Studio is where you'll write and debug your C# code. To prepare it for Unity, install the Visual Studio tools for Unity. The Visual Studio Community Edition is a free and powerful option, perfect for students, open-source contributors, and individual developers. Next, in Unity 3D, we'll create a new project. Launch Unity Hub and select New Project to begin. For demonstration, we'll import basic assets or create simple game objects, like a cube or a plane, within our new scene. These objects will serve as visual feedback for our input actions. We'll then introduce C# scripts to control them. Now, let's dive into keyboard input within Unity 3D, starting with the older, built-in Input Manager. The Input Manager uses functions like input.getKey, input.getKeyDown, and input.getKeyUp to detect key states. GetKey checks if a key is currently held down, getKeyDown detects the moment a key is pressed, and getKeyUp detects when it's released. We can use these to trigger actions, such as moving a player character. Here's a basic example for player movement. The new input system is Unity's modern replacement, offering more flexibility and control over input handling. It introduces input actions assets, control schemes, action maps, actions, and bindings for a structured approach. To use it, create an input action asset. This asset defines all your game's input actions. Within this asset, you can define actions like move forward or jump and bind specific keyboard keys to them. Reading input values from the new input system in a C# script involves subscribing to action events. Next, let's explore mouse input in Unity 3D, covering both the old Input Manager and the new input system. The old Input Manager uses input.getMouseButtonDown, input.getMouseButton, and input.getMouseButtonUp for mouse button states. These functions detect clicks, holds, and releases for the left, right, and middle mouse buttons. You can also get the mouse's screen position using input.mousePosition and convert it to world coordinates with camera.screen-to-world-point. With the new input system, define mouse actions like click or move within your input action asset. Bind specific mouse buttons and movements to these actions, providing precise control. Reading mouse input values, such as button presses or mouse position delta, is done through action callbacks in your C# script. This allows for implementing advanced features like mouse-controlled camera movement or object interaction. Beyond Unity, input handling in Visual Studio for C# applications, like Windows Forms, is also fundamental. To demonstrate, we'll create a simple Windows Forms application in Visual Studio. Keyboard events like key down, key up, and key press can be captured using event handlers on forms or controls. The KeyEventArgs object provides information about the pressed key, including its key code. Similarly, mouse events like mouse down, mouse up, mouse move, and click are handled with their respective event handlers. The MouseEventArgs object provides details such as the mouse position and which button was clicked. Now, let's see how to integrate these input mechanisms with your game logic. In Unity 3D, input values from both keyboard and mouse control player movement, camera, and other game elements. A simple character controller can be created to respond dynamically to these inputs, enhancing player experience. The new input system also excels at handling multiple input devices, including gamepads, seamlessly. In Visual Studio C#, input events can update UI elements or trigger specific actions within your application. You can even move controls, like a button, dynamically based on mouse drag events. Finally, let's cover some essential tips and best practices for robust input handling. Input buffering and debouncing are vital to prevent multiple triggers from a single key press or mouse click, ensuring smooth gameplay. always aim to create customizable input settings, allowing players to rebind keys and mouse buttons to their preference. The new input system's action maps are excellent for handling input differently across various game states, like menus versus gameplay. Utilize Visual Studio and Unity's debugging tools to efficiently troubleshoot any input-related issues. In summary, we've explored setting up environments, implementing keyboard and mouse input in Unity's old and new systems, and handling input in Visual Studio C#. We also covered integrating input with game logic and discussed crucial best practices for robust game development. Experiment with these techniques to craft unique control schemes and enhance your interactive experiences. For further learning, consult Unity and Visual Studio documentation and explore online forums for community support.